Hello, everyone. Welcome to our CS334 presentation on credit card approval prediction rating system. Our team members are Luis and Shengkai. We know that credit scores are very important to all of us. It is a good indicator of our financial behaviors. Having a good credit score makes our life a lot easier. In this project, we are looking for factors that affect our credit scores, as well as building a credit card approval model that is fairly accurate. In the end, hopefully we can explain our model and give people some tips who are applying for credit cards to improve their credit card ratings. The goal of our projects is to obtain a highly accurate credit card approval model based on the data we acquired from Kaggle. By doing this, hopefully we can minimize the risk of defaults on credit cards holders for financial institutions. We'll train many models using different ML algorithms. We'll use the F1 score and ROC curve to evaluate the robustness of each model. Originally, there are two CSV files downloaded from Kaggle. We decided to merge them together. The first one had the applicant's records, for example, their genders and incomes. The second file is fairly simple. It only had applicants' overdue payment status, as well as further last 4 months. We started by merging the two CSV files into one file. We dropped the rows with NA values. We simplified some of the parameters using one hot encoding or the original encoding when it's necessary, or ordinal encoding when necessary. For example, we changed the payment overdue status to zeros and ones, indicating whether applicants is currently in default or not. At the end, we ended up with 14 categorical features, including housing types, family situations, and 4 numerical features like age, employment, time, family size, and income. We then face a very common issue in machine learning: imbalance in dataset target classes. In order to deal with this issue, then get a balanced data set, we use the SMOTE technique. That is an oversampling technique that generates synthetic samples from the minority class. We then use a heat map to obtain the visualized Pearson correlation between variables. We decided to drop car, job, category, phone, cell phone, and family size, which are strongly correlated with other features.
We then divided our data set into training and test data with a 70-30 train test split. Here are the classifications model we trained: logistic regression, k-nearest neighbors, random forest, decision tree, and XGBoost. We'll use F1 score or MSE to assess our model. For the logistic regression, we can see that our results are not satisfying at all, and that this model is of no fit for our kind of problem. Then we use k-nearest neighbors. We see that the F1 score is very good with a score of 89.5%. For random forest, it yields to similar results comparing to KNN with 89.3%. For the decision tree model, the F1 score is of 0.93. And for the XGBoost, it performs slightly better than other models with an F1 score of 91%. Here we can see our summary of the results of our models. We see that XGBoost has the best scores. Same for the ROC curve. The XGBoost has an edge on all the other models with an AUC score of 95.3%. Finally, we can see that our XGBoost is the best model for our credit card approval system based on our training data. Compared to previous analysis, our model performed approximately 10% better and has surprisingly high and accurate results. From our analysis, we extracted the most important features in this assignment. They are the housing situation, the age, the number of children, the housing status, and extra. In the future, we want to implement the support vector machine learning algorithm, SVM. We want to improve our hyperparameter tuning approach and search for a more extensive data set to verify our final model.